Yeah, hi everyone, very nice to meet you all. Thanks for coming along. So I'm George, and today what I really want to do is to share with you all the amazing ways you connect to and control hardware prototypes from the browser. And yeah, there'll be plenty of live demos, so please wish me luck. So for the past few years, I've made a living connecting Arduinos to websites. Basically, my job is to go into big companies and startups and build prototypes of future ideas and test out new ways of working or new product opportunities for them. So there's one example from a couple of years ago here. I'm sat in the front seat of this car with my web page open, and one of my colleagues is riding on the motorbike, and he's got some haptic sensors and lights in his helmet, and I'm trying to navigate him around the streets by sending messages from my laptop. And across everything I make, the common theme is always that there's some sort of screen-based interaction which is complemented and supported by some physical buttons. So like buttons, switches, lights, the small buzz of a speaker or the rumble of a haptic actuator. And the underlying technology is always a browser. And I'm showing you all this because what I don't tell any of my clients is that all my prototypes are basically built exactly the same way. And over the next 20 minutes, I'm going to show you everything I know about connecting websites to Arduinos. So as a heads up, as I said, there's a lot of live demos in this talk. I've attempted them all exactly once before, and they all were perfect. So let's see if we can maintain this record. Today I'm going to cover 3 core techniques: using keyboard emulation, using web Bluetooth, and using web USB in the other order. To help me pitch this right, can you put your hand up if you kind of know your way around an Arduino and what to do with it? Great. And can you put your hand up if you know your way around JavaScript and a bit of like web design? Perfect. Can you put your hand up if you have no idea what I'm talking about? Okay. Right. Oh, and put your hand up if you think you could probably give this talk yourself and you just come here to check what I get wrong. Perfect. Thank you. So the aim of this talk is to show you how to get started in all these areas, the tools, the hardware, the parts you need to buy, and kind of like whet your appetite to go and try it out for yourself. So we're going to start super simple at the beginning and ramp up to some kind of deep code specifics by the end. Everything is a keyboard. So basically everything on your computer can be controlled by keyboard. Every app, action, command has some kind of shortcut. So the theory is if we can program some hardware that will act and work like a keyboard, we can control anything we want without any kind of custom code or anything we need on a desktop at all. So like the Arduino 101, how do you normally make an Arduino talk to a computer? You push a button, sends a signal to one of these pins, it reads it, and it says, oh, if it's pressed, use this serial.print to send a message to the Arduino ID on your computer, and it prints it out. I think if you're more from the JavaScript side, then think of it as like the console.log of the Arduino world in some way. And this is really great. You're probably very familiar with this. But you need a dedicated program on your computer to kind of read and interpret all of these commands. So every USB device is a particular class of device, like a printer or a memory card. These whole like device class sets, mass storage for memory sticks, MIDI for musical instruments. And on a basic Arduino, you've got 2 main chips. You've got this one here, where you put your code, and then you've got this USB to serial converter. And this is the interface to the computer. And it means no matter what code you put onto your Arduino, when you plug this in, it's always going to appear and identify as an Arduino to your computer. This Arduino, on the other hand, has a chip where your code goes, and it has a chip for the USB interface, and it's the same chip. And it means that in code, we can reprogram this to act as a different device, and in particular, a device from this HID, Human Interface Device class. Okay, so here's the complete code you need to turn your Arduino into a computer. This is it. Your Arduino into a keyboard. You include a keyboard library. It comes as default as part of the IDE. You create a reference to the pin, start the keyboard, and then in this loop, we check, are we pushing this pin? If it's low, we write a letter A to the keyboard. This is super simple and extremely dangerous. Okay? Why is this so dangerous? So if you imagine this word low that you might be able to see here, if I'd written this word as high by mistake, it means that the moment I plug it into my computer, it's just going to start typing the letter A as fast as possible. Like, you can't click anywhere, you can't type. It's just going, as fast as you can. You know, you try and upload a new piece of code, but the moment you open the Arduino IDE, it's going, like inside your code, and you just get stuck in this loop. So please, a little piece of advice to you all, save yourself hours of pain and add a small safety stop right at the start of your code if you're ever doing this. All the code I'll share on the GitHub link at the end of this presentation as well. And this means that if the worst happens, you can just plug a small pin into one of these, a wire into one of these pins, act as like a kind of breaker, and it sits in this loop and no more mischief will happen. So as well as accidental mischief, though, you can cause a lot of intentional mischief with this. There's no reason this Arduino has to just send keyboard commands when you push a physical button. So this is a whole program that you need to delete everything that's open on the computer. You go and plug this into one of your friend's computers, and it will do Control-A and press delete on everything that's open right at that moment. Here's another one. You can leave this one plugged in for a while. Every 30 seconds, it will do Alt F4, which is the kind of Windows command for closing the active program on the computer. And this is my favorite. It's like sort of psychological warfare. You can leave, the Arduino can act as any HID, human interface device object, so a mouse or a keyboard or a joystick. And this one will, just nudge the mouse a few pixels every 5 seconds or so. So I wanted to give you a demo of this and sort of do this live on stage, show you how to do it. And I was trying to think of a good one-button game we could play together. And I thought we might try and play this game. So what I'd like to try and do is jump up and down on stage here in front of you and make this Dino jump up and down in the game. So the way we're going to do this is with some aluminium foil. And I'm going to create 2 pads on the floor here. Then I'm going to wrap my whole foot in foil. Great, okay. So, I've got a little program here I think you can see. I'm using a little library to debounce it because this foil's not the most reliable contact electrically on the floor. But effectively, I have this safety stop. I create a new button. I start the keyboard. And then every time that this button gets released, I want to press the spacebar key. And the spacebar key is the key that you can control the Chrome Dino game with. Okay. So I've got a little Arduino that I've put that code onto, and it's got 2 crocodile clips on the end. So if we start playing the game, if I hold these and let go, okay. Now I'm going to connect one of these clips to each of these pieces of foil. And let's see what happens. One more. I've got a really good high score here, as you can see. Okay. Thank you. So So this keyboard method, it works really great if you're only sending this kind of Boolean pressed or no press value. But if you want to capture a more complex range of values or send a message back to the Arduino, we want to do this over Web USB. So the Arduino side is super trivial here. If you recall this explanation from before, we have this serial.print command. It's sending these short text strings over USB. And what the JavaScript Web USB API means we can do is we can capture these messages in the browser just in the same way that we can capture them in the IDE here. So you might have come across this idea before of kind of like plugging hardware into your browser. Drone software updaters use this quite a lot. There's a full Arduino IDE called Arduino Create that actually runs in the browser. It's kind of like Arduino Inception. All of this stuff I'm going to show you only works on Chromium devices, so Chrome, Opera, Edge, those kind of things, and probably will be like that for some time. So I'll show you quickly how this works in JavaScript. To connect, we call this native navigator serial request port function. I'll show you how this works in a second. This triggers this dialog box to pick the device you want to connect to. And this dialog box will look like this. And you can also then filter by the vendor ID. So you only see USB devices manufactured, in this case, by SparkFun Electronics. So each vendor has a unique ID that they pay for. And you can find these in Chrome using this Chrome device log quite easily. It's a pretty handy way to debug Web USB issues. This filtering is kind of optional, but you must set this baud rate in here as well. So that's like the bits per second that you communicate with the Arduino with. And obviously you need to match on the Arduino side and on this side too. So the Web USB API makes a lot of use of the Streams API. The worst way for you to learn about the Streams API is for me to explain it to you right now. But it's just a way of processing like a stream of information, bit by bit, like a file that's downloading. Except here our messages are kind of being streamed bit by bit down the USB cable. So the port that we just opened has this readable stream, and we pipe that stream through a text decoder. And that decodes it from this sequence of bytes that it's sending us to the string that we want to read. And the value is then available when we call this reader.read. So that's it. I'll show you a quick demo of this now. Okay. So this is the device log. I'm going to plug a device into it now. This is like a standard Arduino Uno. And you'll see it appears, it knows that the vendor is Arduino. I can get the vendor ID from here. Then when I hit connect, I can see this. It's a bit small, but you can see it comes up, this device here. So I've got a little tiny little piece of code here. Just running in a loop and just saying hi, 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 and counting up. So if I open the serial monitor, oh, excuse me, hang on a minute. Uh-oh. If I plug this in here, don't know why it thinks it's that. Let's try that. So this guy's just going hi, 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 back and forth. And so this is what you'll see in the Arduino IDE. And that little bit of JavaScript I showed you is also in the web browser here. So if I connect to this device in here, clear all this out, you'll see it's running the same code inside the Chrome console. And as you understand, of course, once you can do that, you can then send any messages that you like between the two. Sending the message the other way is also very similar. We've got a writable stream, and we port this writable stream through a text encoder, and that handles the conversion from the string we want to send from the browser into the bytes. And then we can just write this message by fetching the writer and kind of write a message out to it. And I wanted to give you a more interesting demo than just saying hi over and over again. So I was trying to think of an example of something where you're trying to split the balance between what you can do on the Arduino and what you can do in the browser. I had this idea to build a little musical instrument with one of these pieces of stretch sensor like this. So as I pull this stretch sensor, the resistance of this wire changes, and I'm going to use this to control the musical instrument. So on an Arduino, it's really easy to read in the value of this sensor. I can read in the analog value of this thing, scale it to 0 to 100, and then send it down to the browser. But audio manipulation is often kind of a pain on the Arduino. But on JavaScript, that's really easy, because I can create one of these audio oscillators and use this to vary the frequency of it. And I can show you how this works now. Give you a heads up before it plays. It's not the most impressive musical instrument you'll see this weekend. So I hit connect. And on here. I'm afraid that's all it does. Thanks. So keyboard emulation and web USB, they're a lot of fun, but the real magic is really when you make things connect wirelessly. There's a few ways to connect to an Arduino wirelessly. Obviously, there's a whole family of really popular ESP Arduino boards. A lot of them predominantly use Wi-Fi, but I find Wi-Fi very messy. Like, you're always fighting with access credentials when you change locations. Certificate handling is kind of really hard for HTTPS and stuff. And it's also quite power intensive for battery stuff. So for a lot of the work that I do, I really like to use Bluetooth. It's much simpler. You have a one-to-one mapping of a device to something else, and you can kind of walk into a scenario and demonstrate it, which is exactly what I'm going to do now. So I've got two little bells here. And if you've got an Android phone, you can scan this, and the first two of you to scan this will be able to connect to one of these bells and control them. You can also do this on a laptop with Chrome. Running Chrome, you can type in this URL. So someone's connected to the red, yeah, perfect. Who's got the red bell? Great, and who's got the green one? Okay. You got the power for the rest of this talk. Use it as you wish. The last few minutes of the talk, I'm going to show you how to put this together yourself. Oh, this one's a little, let me tighten that up a bit for you. Great. So there's 3 steps we need to go through using Bluetooth Low Energy: advertise, connect, and then send some data. Bluetooth LE is part of Bluetooth 4.0. It's like the low energy part of it. And Bluetooth LE peripherals, they only connect to one device at a time. Hence, only one of you has connection to this at any one point. Once that device connection is broken, if you were to reload the tab, someone else will be able to connect to it. Thank you. So to connect, Bluetooth LE uses something called GATT, these generic attribute profiles. They define a whole set of services, and these services group together one or more characteristics. So these characteristics will be standard things like a heart rate measurement or battery level, or they can kind of be custom defined. And as with web USB, we send this data as an array of bytes. So I'm using this Bluetooth LE chip from a manufacturer called Nordic, this NRF52 chip. All the demos here use this Adafruit Bluefruit library, which I really recommend using. It's very good and works really well with this chip. So we give this device a name, and unlike with the USB devices, we can choose whatever name we want in the dialog box. So those of you connected, you'd have seen it would have said bell red or bell green when you connected to it. I have no idea why, but you have to call get name immediately after you've set it in order to make it work. It works. Then we set up the service and the characteristics we want to use. So these NRF52 chips, they're really good because they have this UART service, or something that emulates a UART service, this kind of common device-to-device protocol for sending these small messages. And then we can set the way that we advertise it, the length and the frequency and things. And you can pick anything you like here, but I just give you a caveat that these numbers, these 32 and stuff, they're in units of 0.625 milliseconds. Great. So on the JavaScript side, it's very similar connecting to it, the same as with web USB, navigator, Bluetooth, request device. This GATT service, it has a kind of disconnect event, so if one of you were to release this, you'd see the bell go back to gray, and this thing would enable someone else to connect to it. And then we need these wild UUIDs for the Nordic UART service. So to find these, you can either trawl through all the Bluetooth documentation and look for exactly the numbers that you need, or you can just come to this EMF camp talk and I can give them to you. And then the final step is to send and receive the messages, and again, it's very similar to the web USB. To send from the browser to the Arduino, we use this text encoder, convert the string to a byte sequence, and then write to the characteristic. And on the Arduino side, we just loop through, see whether there's any bytes available to read in, and then print them out, and then we get the ding. Thank you. And in reverse on the Arduino, we can use this blue arc top right to send the message across, and then we can read that in, use this change event to see whether something's happened, and read that message back into the browser. And those of you with the bell, you'll have seen it sort of flashes when you press it, and that's how we get that flash back to appear in the browser. Okay, what next? So if you want to have a go at this, maybe looking for what to buy, keyboard emulation works with any Arduino really that has, well, the best thing is any Arduino that says 32U4 or SAMD in the description. This is the chip architecture. I always use these Adafruit Itsy Bitsy ones. I think they're very reliable. For the web Bluetooth, I use anything with this NRF52 in the name. This Adafruit Itsy Bitsy one is very good. These are the ones that are running in these bells right here. For web USB, you can use literally any Arduino. That's the Arduino compatibility. On the browser side, of course, keyboard emulation will just work with anything, browser or not, on your computer. Web USB and web Bluetooth are only Chromium only for now. Obviously, the keyboard emulation is only just a press or release. The others use a byte array. And I'd say that the potential for mischief is very high with the keyboard emulation, perhaps a bit more limited with the other two. So you can scan this to get all of the code for all the demos that I've shared today if you want to have a look at them. Thanks so much for coming along, and hope you have a great rest of the weekend.